Hello guys, I am Abhishek with my project partner Naveen. Our topic for 8051 microcontroller project is remote control car using 8051 microcontroller. This is the 8051 microcontroller and this is motor driver and these are the motors. These are connected with a bunch of buttons connected through wires. Connection is done according to the diagram. Inserting program file in the microcontroller. When I start first switch, all the motors rotate in the clockwise direction. When I off it, all will stop rotating. When I start second switch, all the motors will rotate in anti-clockwise direction. When I on third switch, all the upper motors will start rotating in clockwise direction. And when I on the fourth motor, all the upper motors will rotate in anti-clockwise direction. Now coming to the fifth switch, all the lower motors will rotate in clockwise directions. And coming to the fifth switch, all the lower motors start rotating in anti-clockwise direction. Coming to the conclusion, in the essence, the code translates our commands forward, reverse, left, right into instructions from the motor driver chip, which controls the direction and the speed of motors. This paves the way for building more advanced motors applications. Thank you, one and all.
Hello everyone, my name is Aisha with my teammate Shrija from Electronics and Communication Department 4th SEM B Division. This is a project named Automatic Streetlight using 8051 microcontroller. This is a schematic picture of the circuit diagram. The components used here are sensor used as a button, 8051 microcontroller, transistor, relay, load and an alternator. Now, let us explain the connections. We have three sensors, sensor 1, sensor 2 and sensor 3. These are likely IR sensors or light dependent resistors that detects darkness or motion on the street. When a sensor is triggered, it sends a signal to the 8051 microcontroller through port 1. The microcontroller is programmed to monitor these inputs. When it detects a low signal from any sensor, it activates the corresponding output pin. These outputs drives transistors Q1, Q2 and Q3 which act as switches to energize relay 1, 2 and 3. Each relay connects to a load 1, load 2 and load 3. When the relay is energized, the AC circuit is completed and the street light turns on. The automatic streetlight system using 8051 microcontroller efficiently controls streetlights based on sensor inputs, turning them on only when needed. This enhances energy savings, reduces manual intervention, and provides intelligent streetlight control. By this, we conclude our overall presentation of the circuit. Thank you.
Hello everyone, I am Vinayak Aminoi with my project partner Omkar Angadi. We are from ENC Department 4th B Division. Our project name is Automatic Streetlight Control using 8051 microcontroller and digital clock using 8051 microcontroller. The automatic streetlight using 8051 microcontroller is made using 8051 microcontroller with Key software and Proteus software. This project helps us in not only streetlight controlling but in applications like smart parking systems, smart traffic light systems, and many more. When some of the benefits are energy efficiency, cost saving, and improved safety. Here is the code used for this project.
Here is the Proteus simulation of the project Automatic Streetlight using 8051 microcontroller. Components used in the circuit are card with enabled sensors, 8889C51 microcontroller, 3 transistors BC547, 3 relays, 3 lamps with an alternator. Here is the simulation result and result of the project. When the sensor 1 is activated, when the car is detected, the lamp 1 glows. When the car is detected by the sensor 2, the lamp 2 glows. Similarly, when the car is sensed by the sensor 3, the lamp 3 glows. When the car is not detected by any of the sensors, the lamp will not glow and will be turned off. Here is our second project, digital clock using 8051 microcontroller. This project involves the design of a digital clock system that displays real-time hours, minutes, and seconds using an 8051 microcontroller. The primary objective is to use the microcontroller's delay keep accurate time, and display it on a LCD or 7-segment display. Some of the benefits are real-time accuracy, compact and customizable, reliable operation. And here is the code of this digital clock project. Here is the Proteus simulation of digital clock using 8051 microcontroller, which uses the components 8089C51 microcontroller with 7-segment display. Note that this timer works only for 12 hours and it restarts again from 0 to complete 24 hours. And here is the end result of the project. While programming, we gave the delay of 130 milliseconds so that it counts 1 second. Here is in the display, first and second digit displays seconds, while the third and fourth digit displays minutes, and similarly with fifth and sixth digit displaying hours. Here you can see the timer counting 2 minutes 58 seconds. As the counter exceeds 60 seconds, the minute counter increments to 3.
Hello everyone, this is the simulation of object counter using microcontroller. So here in this we use components like IR obstacle sensor, crystal oscillator, capacitor of 32 picofarad and 10 nanofarad and resistor of 8.2K and LCD display, microcontroller AT89C51 and a trigger. So let us see the brief working of the circuit. When the system is powered on, the 8051 microcontroller begins by initializing the LCD display. The LCD is connected to port 2 for the data lines and two control pins RS and EN are connected to port 3. The LCD shows starting message, object count and displays the initial count which is 0. An IR sensor is connected to pin 1.0 of the microcontroller. This sensor works on active low logic, meaning it outputs a low signal 0 whenever a person or object interrupts the IR beam. The microcontroller enters an infinite loop where it continuously monitors the IR sensor. When the IR sensor detects an object, the program waits for a short time to filter out any noise or false triggering. After the small delay, it checks the sensor again to confirm the detection. If the object is still present, the microcontroller increments the count variable by 1. Immediately after incrementing, the new count is displayed on the LCD, replacing the old value. Here is the code. So let us see the working how it works. When the object enters or triggers, it is incremented by 1. Like this, it works. Thank you.
Hello everyone, myself Parvamdi with my teammate Pratik Kunkund. Our project is Water Level Indicator using 8051 microcontroller. This system mainly works on principle of water conduct electricity. Tank contains 3 wires at the different levels at lower, middle and upper level. These wires are used to check the levels of tank to turn on or off the submersible pump. When the water level of tank goes below the lower wire, then the ground is disconnected, with which the high signal is sent to the P1.2 port pin of microcontroller, and it also checks tank also has water or not. As per the program, microcontroller sends high signal to P3.0 pin and P3.0 is connected to BC547 transistor. This transistor acts as a switch for the relay. When this transistor receives high signal, it acts as close switch and turn on the motor. The LCD will display its message that tank is empty. When the water reaches the middle level, LCD displays tank is middle and still motor is on. When the tank is full, it sends low signal to microcontroller P1.0, and as per program, microcontroller send it to P3.0, and then transistor acts as open switch. Relay ID disconnected with ground, motor is turned off and LCD displays the message tank is full and motor is off. We can conclude that this system has demonstrated sufficient potential in monitoring and controlling water levels in various applications. The system abilities to provide real-time water level status and automatic control of water pumps based on predefined levels showcases its efficiency and reliability. Thank you.
Hello everyone, I am Praveen Kumar with my ally Sagar. We are explaining the working of digital clock using 8051 microcontroller. This is a simple digital clock circuit using 8051 microcontroller and a 7 segment analog display. At the heart of the design is 8051 microcontroller which controls the entire clock logic. It is connected to an 8-digit 7 segment display that shows the time in hours, minutes and seconds. Port 2 of 8051 sends segment data to the control which segment lights up. Port 1 is used to select which of 8 digits on the display is currently active using the concept of multiplexing. Only one digit is turned on at a time, but switching happens fast enough that all digits appear lit simultaneously. An internal timer in 8051 keeps track of time by generating delays and updating the digits every second. The microcontroller runs in a loop to increment seconds, minutes and hours accordingly and then updates the display using predefined 7-segment codes called as hex codes. This compact design is great for learning digital timekeeping with embedded systems. Thank you.
Hello everyone, I'm Hafsa and my teammate is Priyanka. We have done a simulation project on fire alert system using the 8051 microcontroller. This is the circuit and the circuit comprises of a sensor, a microcontroller, a buzzer and an LCD display. When the sensor detects a fire, it sends a signal to the microcontroller which in turn gives the input to the buzzer and it starts buzzing and the LCD displays the occurrence of a fire. This is the code that we have used.
Hello everyone, I am Shushti Kagvimat with my project partner Priyanshi Yadav. We are from ENC department of 4th SEM B division. Our project is toggle LED using 8051 microcontroller. So the components used here are AT89C51 microcontroller and LEDs. Toggling an LED means turning it on and off alternately at regular intervals. This is usually done using microcontroller program that sets a digital output pin high to turn on the LED and low to turn it off in a toggling fashion. When we run the simulation, we will see that the LED is blinking. The speed of the blinking depends on the delay programmed in the code. This visual on and off action is called as toggling effect. Applications of toggling LED in real life are as follows. They can be used as status indicators, they are used in error and warning signals, they are used in traffic lights, in communication signals, in alarm and security systems. This was the working and application of toggle LED. Thank you.
Voting machine using 8051 microcontroller. An electronic voting machine using 8051 microcontroller allows user to cast votes through push button switches, each representing a candidate. At the end of the voting process, the microcontroller displays the results on the LCD, showing the total votes for each candidate. Let us start with the stimulation process. To start the stimulation, we have to press the start push button. And the party names will be displayed. User has to cast vote for one and only one party. By pressing start button again, the circuit will be restarted. Again the party names will be displayed. We have to cast vote for one party. The votes will be counted. To display the votes, we have to press result button. Votes received by each party is displayed. At last, the winning party is displayed. Thank you.
Everyone, myself Pranati and my teammate is Ranjana. We are making the project on microcontroller. Our project name is Object Detection using Ultrasonic Sensor. We are using some basic components like AT89C51 microcontroller, ultrasonic sensor, 7-segment LED display and oscilloscope. For simulation purpose, the output of the circuit is seen in Proteus simulation. The ultrasonic module is interfaced to the microcontroller through port 3.0 and port 3.1 pins. Port 0 used for transmitting the 8-bit display data to the display, and the port pins P1.0, P1.1, P1.2 are used for the transmitting display drive signals for the corresponding display units D1, D2, D3 for simulation purpose. We have used resistor pot as it keep on varying. The display unit displays the distance of the object. The trigger pulse and the echo output are seen in the oscilloscope. The trigger pulse has an amplitude with 10 microseconds. The width of the echo output is proportional to the measured distance. Conclusion. Ultrasonic sensors are widely used in many applications such as domestic and industrial purpose. By this experiment, we can build distance measurement tool, automated parking system and level measurement.
Everyone, myself Rashmi and my teammate is Shraddha. We are making a project on microcontroller. Our project name is Gas Leakage Detection using 8051 microcontroller. We are using some basic components like 8051 microcontroller, LCD display and MQ2 gas sensor. Before this, we execute a C program code. Here is our C program code. After executing this, we should simulate this in Proteus. Here, when the logic state is 0, after simulating this, the MQ2 gas sensor will not detect the gas. So, the LCD will display the gas is not detected. After, when the logic state is 1, the MQ2 gas sensor will detect the gas. After simulating this, the LCD will display the gas is detected. This is our project. The overall conclusion here is when the MQ2 gas sensor will sense the gas, then the LCD will display the gas is detected, and when the MQ2 gas sensor will not detect the gas, the LCD will display the gas is not detected. Hence, thank you.
Hello everyone, I am Sumit Sankoji and here is my teammate Sachin Ballari. We are from ECB 4th SEM. So today we are going to explain how traffic light stimulator using 8051 microcontroller. Two traffic lights are given, one in the direction of north-south and another in the direction of east-west. When the north-south light indicates red and the vehicle stops over there, when the east-west direction light given green, the vehicle moves. Here is the code which we have used for the automation of traffic light simulation using 8051 microcontroller.
Hello, my name is Aditya Kulkarni. Me and my friend Sai Kiran have made a project on the topic Ultrasonic Range Finder using 8051 microcontroller. The components required for this project are the 8051 microcontroller IC, the ultrasonic sensor, and the 16:2 LCD display. The working principle for this project is The 8051 microcontroller sends a trigger pulse to the ultrasonic sensor to initiate the transmission of ultrasonic waves. The sensor emits ultrasonic waves which bounce off an object and return as an echo. The sensor outputs a signal proportional to the time taken for the echo to return. The 8051 microcontroller measures the duration of the echo signal and calculates the distance using the given formula. The calculated distance is displayed on an LCD display connected to the microcontroller. The code for this project is given here. This is the initialization and delay functions. These are the LCD and distance measurement code. And this is the main function setup and the welcome message, which is optional, and the main loop for the code. Here you can see the simulation of this project.
Hello everyone, this is the automatic railway gate using assembly code. This system is designed to manage the control system of railway gate using the 8051 microcontroller. The components used in are 8051 microcontroller, one L293D motor driver IC, one DC motor, one LED green light, and another LED red light, one buzzer, IR sensor 1 to detect the train coming, and IR sensor 2 to detect the train going. As green LED will be on before detection of the train. As train approaches the railway crossing, the sensor placed at certain distance from the gate detects the approaching of train and informs the microcontroller about it. This signal is used to trigger the microcontroller for opening or closing of gates. As train approaches, the IR sensor 1 gets detected. The green LED gets off and red LED gets on. DC motor turns in a clockwise direction, and as train passes completely through IR sensor 1, the IR sensor 2 gets on and red LED gets off, and DC motor turns in an anti-clockwise direction and green LED gets on back. And this is the assembly code.
Hello everyone, this is a simulation of home automation using 8051 microcontroller. Here we used components like relay, loads, alternate source, switches, 8051 microcontroller and virtual terminals. Now we will see the working of the circuit. When the user provides input through digital interface connected to the microcontroller, each button corresponds to a particular relay or load. The microcontroller reads the inputs based on the input and it sends high or low signals to its output pins, which is connected to the relay. A high signal activates the relay and it completes the circuit for the respective AC load as turning it on, and deactivating the relay turns the load off. When the user gives 2, 4, 6, 8 as inputs, the loads turn on, and when he gives 1, 3, 5, 7 as the input, the loads turn off. When the user gives 9 as input, all the loads turns on, and when he gives 0 as input, all the loads turns off. In the end of the video, we have provided 8051 microcontroller code for the given simulation. Thank you.
Hello everyone, my name is Sania with my teammate Vaishnavi. We are from Electronics and Communication Department, 4th SEM B Division. This is our project named as Automatic Door Locking System using 8051 microcontroller. This is the schematic picture of the circuit diagram. So the component used here are, first one is button and 8051 microcontroller and L29 3D driver, and last one is DC motor. Now let us explain the connection. Sensor, which is used as a button, it sends a digital high or low signals to the microcontroller, where the one end of the sensor is connected to the ground and another one is connected to the pin 0 of the port 1 of the microcontroller. So microcontroller receives the signal from the sensor. Based on these input, it decides whether to lock or unlock the door. It sends signals to the L29 3D motor driver. B29 3D driver. It acts as interface between the low power microcontroller and high power DC motor. It takes input signal from the microcontroller and controls the motor connected to it. Based on the input from the microcontroller, it derives the motor clockwise or anti-clockwise. Last one is DC motor. The motor rotates to either lock or unlock the door mechanism. This is the program which is executed. So now we run this. I will turn on the button. Here we can see that the motor start rotating in clockwise direction, which means that the door is opened. And at some delay, it will stop rotating clockwise and starts rotating in anti-clockwise, which means that the door is closed. This was the working and explanation of the door operation. Thank you.
Hello everyone, my topic is robotic car using 8051 microcontroller and L293D motor driver. I have executed this using Kill software and Proteus. In this circuit diagram, it typically works by interfacing the 8051 microcontroller drivers with via general purpose input-output pins. Based on this input, it sends signal to the L293D motor driver to control the direction and speed of the motors. Here, L293D is a popular integrated circuit used for controlling DC motors. It can drive up to motors bidirectionally. That is, it can control the direction as well as the speed. It is commonly used in robotics and other projects where motor control is required. And thus we have used a DC motor. It is an electrical motor that operates using direct current electricity. It converts electrical current into mechanical current. Through the interaction of the magnetic fields, it is commonly used in a wide range of applications from household appliances to industrial machinery. We have used 12 volt of DC power supply. So now I am going to simulate the circuit. As we have explained in the code, when we click on a forward button, all motors will rotate in the clockwise direction. And when we click on the backward button, all motors will rotate anti-clockwise direction. When we click on a right button, upper two motors will rotate in a clockwise direction and lower two buttons will stop. Then when we click on a left button, upper two motors will rotate an anti-clockwise direction and lower two motors will stop. So this is all about my project. Thank you.
Hello everyone, I am Vishal along with my teammate Sayam from 4th Sem ECE. I am here to explain about the simulation of my project, that is stepper motor interfacing using 8051. This is a stepper motor interfacing circuit using an 8051 microcontroller and a driver. The microcontroller sends signals from port 2 to the driver, which acts as current amplifier. Since the microcontroller can't provide enough current to drive the stepper motor directly, the driver receives these low power signals and switches the required higher current to the motor windings. The motor is a unipolar stepper type and its 4 coils are energized in a specific sequence to rotate the shaft step by step. The 10K resistor and capacitor from a reset circuit to initialize the microcontroller at startup. The COM pin on the driver is connected to a high voltage source to power the motor coils. By changing the sequence and timing of signals sent from port 2, we can control the direction and speed of the motor's rotation. This setup is commonly used in robotic arms, printers and CNC machines for precise position control. Thank you.
Hello everyone, myself Savita with my teammate Vidyashri. Our project is Dust Level Indicator using 8051 microcontroller. This is the schematic picture of this circuit diagram. Here, the components used are 8051 microcontroller, which is 8089C51, the dust sensor BPD42, analog to digital converter ADC0804, and 4 LEDs. Let us discuss the working of the circuit diagram. Here, firstly, the dust sensor detects the dust particles present in the air. How it detects means it contains IR light and photodiode. When the dust particles enter the chamber, they scatter the IR light. This scattered light is detected by the photodiode. Amount of the scattered light corresponds to the dust concentration. That sensor provides an analog voltage output that increases with the dust density. Here, the output pin of the dust sensor is connected to the V input plus pin of the ADC, and V input minus pin is connected to the ground. It converts analog signals to the digital signals. Then digital signals are sent to the 8051 microcontroller. The output is taken from the port 2, which is connected to the 4 LEDs. The first LED, which is green, indicates the low dust. The yellow LED indicates medium dust, and red LED indicates high dust. The last one, red LED, indicates very high dust. The simulation result is like this. Here, the green LED is glowing, which indicates that the concentration of dust in the air is low. Conclusion: the dust level indicator project can be used for various applications, mainly on monitoring dust concentration in the air or dust levels in the containers. These indicators can be used to assess air quality and optimize dust collection systems. By monitoring the dust levels, it is possible to ensure that workers and occupants are not exposed to unhealthy levels of dust or pollutants. Thank you.
Hello everyone, I am Shambhavi with my project partner Rakshita and Srividya. We are from EC department. With the fourth semester, our project is Basic Calculator using 8051 microcontroller. Introduction. This project is all about basic calculator using the 8051 microcontroller and an assembly language software program. And this is a small electronics project. It is made using a simple components like keypad and display. This project is useful for learning how microcontroller works. It is commonly used in electronics and embedded systems. Now I show you the project. Basic calculator using 8051 microcontroller. The components consist of keypad, microcontroller 8051 and 16 into 2 LCD display. Now we start the project by clicking simulation button. After clicking the simulation button, the LCD displays calculator please press on. For the operation to be needed, we need to press the on button on the keypad. For the further operations, we need to select the two numbers and the plus button for the addition and the two numbers. And for the result, we need to press is equal to button. And here we got the output as 34. 14 plus 20 is equals to 34. To clear this, we need to press again on or on slash clear. Now, for further operations like subtraction, multiplication, division, we need to press any two buttons into 2. And for the result, and the result is 244. Or for the further clear, we need to press on or slash clear button. For further operations like multiplication and division, like this, we need to operate the basic calculator using 8051 microcontroller. Now, this is about a conclusion. The basic calculator using 8051 microcontroller successfully performs a fundamental arithmetic operations like addition, subtraction, multiplication, and division. It demonstrates the practical application of embedded system in handling the user input, processing data, and displaying result efficiently, making it a useful project for understanding microcontroller-based system designs. Thank you.
Hello everyone, this is Shashwat along with Nakul. We are fourth semester electronics and communication students at SDM CET Dharwad. Today I'm here to explain my project, which is basically about gas leak detection system using an 8051 microcontroller and an MQ2 gas sensor. The MQ2 gas sensor is used to detect combustible gases like LPG or smoke. When gas is present, The sensor outputs a high signal which is read through 7th pin of port 0 of the microcontroller. In the code, this input is continuously monitored. If gas is detected, the microcontroller turns on the yellow LED connected to the 3rd pin of port 0 as an alert. The LED blinks 5 times for visibility. Simultaneously, the LCD displays the message gas detected. If no gas is detected, the LED remains off and the LCD displays gas not detected. The LCD is connected to port 1 of the microcontroller and is controlled through RS, RW and E pins from port 2. Proper initialization commands are sent at the start to configure the LCD in 8-bit mode. This setup is basic safety alert system useful in kitchen or industrial areas where gas leaks need immediate attention. Thank you.
Myself Shriyari, my friend Srinivas, we have did the automatic door locking system using the 8051 microcontroller. The software used here are Proteus and Keel software. The component used are button, AT89C51 microcontroller, motor driver, DC motor. Now I will simulate this. On the button. The DC motor start rotating in clockwise. This means that the relay 1 equals to 1, relay 2 equals to 0. If the motor rotates in clockwise, the door opens. After some delay of time, closes of the button, DC motor slowly stops and then rotates in anti-clockwise. This means that the door is closed. Thank you.
Myself Shruti Chavan with my teammate Sindhu Sidram Gold. We have done project on interfacing of soil moisture sensor. The components used in this project are AT89C51 microcontroller IC, LED display, DC voltmeter and a soil moisture sensor. As we all know that there should be a proper content of moisture in the soil for the better yield or the growth of the plants. The soil moisture sensor will detect the humidity or the moisture content in the soil. The analog output will be displayed on the DC voltmeter and the digital output will be displayed with the message content in the LED display. As we go on increasing the resistor value, the moisture content in the soil decreases and same as that of the vice versa. This project mainly enables farmer to monitor and manage the soil moisture variability with the fields. In the conclusion, we are able to understand the working principle of soil moisture sensor and how its data can be effectively used for the automation, particularly in the irrigation system. Thank you.
Hello everyone, I am Sindhu Patel with my partner Surabhi from ENC department 4th semester. Our project is automatic light sensor using 8051 microcontroller. This is the code for the project. Now let us discuss about the circuit. The components here are AT89C51, crystal oscillator, resistor, capacitor, LDR and LED. Now let us go with the connections. Pin number 18 and 19 is connected to a capacitor of 33 picofarad and a crystal oscillator of 12 MHz is grounded. Pin number 9, that is reset, is connected to a capacitor of 10 microfarad and a resistor of 10K which is connected to VCC. Pin number 1 is connected to a resistor of 10K which is then connected to VCC and a LDR is connected to a ground. Pin number 21 is connected to a resistor of 330 ohm and a LED which is grounded. Now let us go with the working. Light falls on the LDR causing its resistance to change. This change in resistance alters the voltage at the input pin of the microcontroller connected to LDR and R2. The AT89C51 reads this voltage. Based on a program threshold, the microcontroller decides whether the light level is above or below a certain point. The microcontroller then drives its output pin connected to LED, turning it on or off to indicate the light conditions. Now let us stimulate the project. You can see directly the LED glows. This is the fundamental example of how a microcontroller can be used to sense environmental conditions and react accordingly. Thank you.
Hello everyone, I am Saurabar from Electronics and Communication Engineering Department at STMCET Dharwad. This is my project titled as Automatic Staircase Light Control System using 8051 microcontroller. The main goal of the project is to control stair lighting automatically, saving the electricity and enhancing the safety. As the name indicates, it automatically turns on or off of the LED only when someone or something is present on a step of the staircase. To achieve this, I have used 8051 microcontroller, infrared sensor and LED stands for light emitting diode. If we come to the schematic of the project, here I have assumed 5 steps for the staircase, so I have used 5 IR sensor and 5 LEDs. The IR sensor outputs are connected to the port 0 of the 8051 microcontroller and the LEDs are connected to the port 2 of the 8051 microcontroller. Now let's look at the simulation. Here you can see how the IR sensors and LEDs are connected to the 8051 microcontroller. When I press a toggle button, it simulates someone stepping on a stair. The IR sensor sends a signal to the microcontroller which processes the data and turns on the corresponding LED. The previous LED turns off and this continues step by step as the person climbs. If we come to the conclusion of the project, this project helps control staircase lights automatically using sensors and a microcontroller. It turns on the light only where it's needed and turns off the rest, which saves electricity and improves the safety. It's a useful system for smart homes and buildings. Thank you.
Everyone, I am Aishwarya and my teammate is Suma. We are doing the project visitor counter using 8051 microcontroller. My components are 2 infra sensors, 1 8051 microcontroller and 1 LCD display. Now I am going to show the code in Keel software. See, this is my code and I am going to execute the simulation. This is entry. If the person enters, then it will census and shows the entry count. And this is exit, which shows the exit count. And this is the basic overview of our project. Thank you.
Hello everyone, myself Tanish Bekal and my team partner is Sanjeev Patanshetty from EC department. Our topic is digital thermometer using 8051. Our faculty in charge is Dr. S.V. Viraktimat sir. This is the snapshot of the digital thermometer. Here we used LCD display, microcontroller AT89C51, temperature sensor LM35, ADC 0804, potentiometers RV1 and RV2. So the working of our simulation is microcontroller AT89C51. It is the main controller that processes digital temperature data and displays it. It connects to a crystal oscillator for clock input with two 33 picofarad capacitors. Temperature sensor LM35, analog sensor that outputs 10 millivolt per degree Celsius. The output is connected to pin 6 of the ADC0804. It provides analog voltage corresponding to temperature. ADC, analog to digital converter. It converts analog output from LM35 to digital data. It requires the clock signal generated using R10 and C4. It reference voltage to control conversion range. The control pins are connected to port 3 operation. LCD display LM016L. It displays the temperature reading. It is connected in 8-bit mode to port 2 of the microcontroller. The control pins are also connected to port 2, shown like the temperature 31 degrees Celsius. Potentiometers RV1 and RV2. The RV1 controls the contrast of the LCD. The RV2 might be used as a variable reference or for simulation adjustment of sensor voltage. When the voltage is varied, the temperature is increased or decreased. Here is the program of our circuit. Conclusion: the designed thermometer circuit effectively demonstrates the integration of a temperature sensor, analog to digital converter and microcontroller to measure and display the temperature in real time by utilizing the LM35 sensor for accurate analog temperature sensing. The ADC0804 for precise digital conversion and the AT89C51 microcontroller for data processing and display control. The system provides a reliable, low-cost solution for temperature monitoring. This project showcases fundamental principles of embedded systems and serves as a practical application in environmental sensing and control systems. We will show the simulation of the digital thermometer.
Hello everyone. Myself Tanishka with my teammate Sanjana. Today we are here to present a project titled Automatic Door Lock System with Object Detection using 8051 microcontroller. The objective of this project is to automate the locking and unlocking of a door by detecting the presence of an object or a person. This system consists of four main components: a 8051 microcontroller, a L293D motor driver IC, a push button as an input, and a DC motor to operate the door lock. Here is the code for our system. The microcontroller is programmed to monitor the button input. When the button is pressed, the program sends a signal to motor driver to rotate the motor for unlocking. After the delay, the motor reverses to return the lock to its original position. Here is the Proteus simulation of the project. This is the button, this is the microcontroller, this is the L29 3D motor driver, and this is the DC motor. So here, when I press the button, the microcontroller receives the input and sends control signals to the motor driver. As a result, the motor turns unlock the door. After a few seconds, the motor reverses the direction to lock the door again. Here, the button is connected to port 1 of the microcontroller. When the button is pressed, it sends a high signal to the microcontroller. And here, the microcontroller is programmed to detect this input and sends control signals from pins port 1.1 and port 1.2 to input 1 and input 2 ports of the L293D motor driver. The L293D receives these signals and controls the motor connected at out 1 and out 2 to rotate in a particular direction, either locking or unlocking the door. So when I unpress or when the button is released, the input at port 1.0 goes low that is logic 0. So the microcontroller detects this low signal and it can do nothing if no action is programmed for low input. So when the button is pressed again, the microcontroller receives the signal, causing the motor to rotate in the opposite direction and thus locking the door again. And so this process continues. So here is the simulation of our project. Thank you.
Hello everyone, myself Dhanam and my teammate is Triveni. Here firstly we have used a microcontroller IC which acts as a current withdraw source, a step motor and some basic components. The motor requires more current than the microcontroller can supply. So the UVLN2003A acts as an interface to safely drive the motor coils. The 8051 microcontroller sends signal from the port 2 to the input pins of the IC. The ULN2003A is a transistor array that amplifies the low current signal from the microcontroller and drives the motor windings through its output by sending the appropriate binary pattern to port 2. The 8051 rotates the motor in steps either clockwise or counterclockwise depending on the order of activation. The common pin of the ULN2003A is connected to high voltage and used for the internal freewheeling diodes to protect against back EMF generated by the motor. Here is the code for our project. On simulation, it's the working of circuit. Thank you.
Myself Vaishnavi and my teammate Samrama. Our project is digital clock using 8051 microcontroller. The schematic diagram of our circuit looks like this. Here we have used 8051 microcontroller, 7 segment LCD display and 6 inverters. Let us see how it works. When we click on run button, the LCD starts to display. And here these two digits of LCD represents the seconds and these two digits represent minutes and these two digits represents hours. Let us quickly glance the code of our project. And here we have used inverters to activate the segments and the digits of the LCD. And the port 1 of 8051 microcontroller is responsible to glow the segments of the LCD and the port 2 of 8051 microcontroller is responsible to glow the whole digit of LCD. That's all about my project. Thank you.
Hello everyone, now I am going to explain about the project titled as Password Based Door Lock System using 8051 Microcontroller. Principle: a password based door lock system is an electronic locking mechanism that opens only when the correct password is entered. It uses a microcontroller, LCD display, keypad, and motor to operate the lock. If the correct password is entered, the door unlocks, otherwise it remains locked. How it works: the user enters a password on the keypad, the microcontroller compares the entered password with the predefined one. If the password is correct, the microcontroller activates the relay or transistor, triggering the activator to unlock the door and the LCD displays correct. Unless if the password is incorrect, the LCD displays incorrect and the door remains locked. These are the components used for the simulation of the circuit. This is the 8051 microcontroller, 16x2 LCD display, the motor driver, motor and 4x3 keypad. The snapshot of the Proteus simulation. This is the microcontroller, the core of the system, handling keypad input, password verification and controlling the motor and LCD. The most important pins are port 1, P1.0 to P1.7 connected to the keypads for reading user input. Port 2, P2.0 to P2.7 are connected to the data pins D0 to D7 of the 16x2 LCD. Port 3, P3.2 and P3.3 are connected to IN1 and IN2 of the motor driver to control the motor direction. And the output of this IC is connected to the motor to stimulate door movement. This is the program used for the simulation of the circuit. Now Let us simulate our circuit. First, click on the Simulate button to run the simulation. Now, LCD displays as a message as password. Then, the user is allowed to enter the password through keypad. We have predefined password as 1234. So when the user enters the correct password, the motor starts rotating and the door is unlocked and LCD is displayed as correct. If the user enters the wrong password, then the door is locked and the LCD is displayed as incorrect. Conclusion: the password-based door lock system utilizing 8051 microcontroller, LCD interface, and 4x3 keypad has been successfully developed. Though effective hardware integration and software implementation, the system accurately handles user inputs, displays messages, and controls the locking mechanism. Thorough testing ensures reliability, demonstrating practical application in security contexts. Future improvement may focus on additional security features and scalability. Overall, the project showcases embedded system designs and practical implementation skills. Thank you.
Hello everyone, this is a simulation of temperature based fan, which can be vary their fan speed according to the temperature varies. In this simulation, we used LM35 sensor, ADC converter and 8051 microcontroller with the oscillator, and we used a motor as a output. Here we connected LM35 sensor to the ADC converter because the microcontroller can't be able to take the input as analog signal. So we convert the analog signals of the LM35 sensor into the digital converter. So we use the ADC to convert it, and after that microcontroller can take the output of the ADC and pass to the crystal frequencies, which is nothing but make a stable and accurate of the project output. So after this it passes to the P1 pins to the output pins to the motor. So the motor varies when the temperature varies. So here we can go with this. Here we run the project. You can see here motor was running. We increase the temperature. Look at here, 48, 50 degrees Celsius. According to this, here the fan is moving, and we connected AC volts meter, so you can verify the temperature. According to the temperature, the voltage also is increasing. So here we make a 50 plus 52, 54, 58. How we can change the LM35 sensors temperature? So here we can see the AC volts as a more. So thank you. This is a project.
Hello everyone, this is Vishal along with Prajwal as my partner. We are 4th semester Electronics and Communication students at SDM CET Dharwad. Today I am going to explain our project, which is basically about water level indicator using 8051 microcontroller. The main components in this project include the microcontroller, 4 push buttons to simulate water levels, 4 LEDs as indicators, an LCD display and a DC motor. The push buttons represent water level sensors placed at 25%, 50%, 75% and 100%. When a button is pressed, it simulates that the water has reached that level. The microcontroller checks which switches are pressed, and based on that condition, it returns the water level and displays the result on the LCD. For visual feedback, 4 LEDs light up progressively. If only the first switch is pressed, LED 1 turns on and 25% is shown on the LCD. As more switches are pressed, more LEDs turn on to indicate higher levels up to 100%. The motor is controlled using L293D driver. When the tank is not full, the motor is turned on. Once the water reaches 100%, the system automatically stops the motor. This setup provides a simple yet effective way to automate water tank filling. It ensures that the motor only runs when needed, conserving energy and preventing overflow. Overall, it demonstrates how embedded system can solve everyday problems effectively. Thank you.
Hello everyone, this is Somesh with my teammate Sagar. Our topic is about electronic piano using 8051. This project demonstrates how an 8051 microcontroller can be used to generate musical notes through a speaker by pressing switches, simulating a basic piano. This is a schematic representation. The main components used are AT89C51 microcontroller, buttons, and speaker. Working. There are 8 buttons connected to a different input of port 1, that is from P1.0 to P1.7. When a button is pressed, the microcontroller generates a specific frequency corresponding to a musical note. Different frequencies simulate different piano notes. The generated square wave is output through port 2.0 to a speaker. The conclusion. The piano circuit is a fun and educational project that helps students learn about frequency generation, 8051 microcontroller programming, and hardware interfacing. It bridges digital logic and real world sound production in a simple and effective. Hello everyone, this is Somesh with my teammates Parameshwar. Our topic is about electronic voting machine. An electronic voting machine (EVM) is a hardware device used to record votes electronically instead of using paper ballots. It ensures faster counting, accurate results, and avoids the hassle of manual voting. This is the schematic representation. The main components required for this circuit are AT89C51 microcontroller, buttons, and LCD display. The working is as follows. Firstly, we have to press the initial button to initiate. Then we have to cast the vote. Again, we have to initiate by pressing the initial button. Every time after the casting of vote, we have to initiate. For seeing the results, we have to press the result button. The results are displayed in LCD display. The conclusion. The EVM project successfully demonstrates the use of embedded systems to create a fast and user-friendly alternative to traditional paper-based voting. Overall, it serves as an effective prototype for secure and efficient voting system in small-scale environments. Thank you.